Hello, Allison.
Hi.
Great to see you, and thank you so much for taking the time. As I explained earlier, we're celebrating 20 years of World Haptics Conference, so we like to get some insight from people from different background and all that, especially because you cannot attend this year. So we really appreciate that you can share your thoughts and insights with us through a video.
Thanks so much for including me. Really appreciate it.
Well, thank you. Let's dive right in. To begin with, I wonder if you could just talk about the three key scientific or engineering achievements that you see the whole field has made in the last 2 decades.
Yeah, so I think the most important one, which maybe is more of a conceptual idea than a specific technological contribution, but one of the things I most appreciate is Vincent Hayward's progress on haptic illusions and just the concept that what we often need to be doing when we create haptic stimulus to create certain perceptions is we have to trick people. And Vincent, who, as you know, is now passed, is just brilliant at defining ways in which, through relatively simple mechanisms, you could generate these haptic illusions. So many technologies, I think, have come out of that idea. He's talked about it long before 20 years ago, but I think it really caught on conceptually a little less than 20 years ago. The second one I would say is wearable haptics that use skin deformation techniques. Partially, this is my own work, but also many others have contributed to this. The idea that by displacing the skin locally, normal, and in shear, you could create a whole wide variety of touch sensations, going beyond kinesthetic feedback from the original, very capable haptic devices that were based on robotic mechanisms like the Phantom haptic device, but moving on to providing that information not as a net force, but rather a local force onto the skin, and yet still enabling people to feel really rich directional feedback. That's would be my second contribution. And then for the third one, I think this is still ongoing. We haven't totally figured it out, but using combinations of smart and soft materials to make haptic devices more portable, more wearable, less power hungry, we hope in the end. I don't think these approaches have yet gone all the way to commercial products and very wide application. But this idea that rather than using traditional electromagnetic actuators, we should be starting to use smart materials, soft materials, to make haptic devices more wearable has been a really exciting development, especially in the last 5 to 10 years.
Hmm. Yeah, no, thank you. So illusions, wearables, and smart materials.
Right.
Yeah. So you mentioned a little bit about some of them have not made to the commercial world yet. Of the products that exist nowadays, which ones comes to mind that have benefited from haptics?
Yeah, so vibration feedback has really been the thing that has gotten into products the most, right? Everyday use, whether it's in cell phones or smartwatches or in cars, controllers in vehicles, controllers in the car that lets me know if I've gone out of the lane. Vibration feedback has really, it's fully integrated into these types of products, and it's relatively low cost. It's such a salient form of feedback. I guess I don't list it in those sort of last 20 years new progress, because it has been well known for a very long time that vibration feedback could and is great for products. Yeah, we also know it has limitations, right, in terms of how much information and how accurately people can interpret vibration information. So it's great to see that in so many products. We just have a lot of work to do to get more sophisticated forms of information like the ones that I just highlighted as new breakthroughs actually into products, because I think that's much rarer.
Mm, yeah, I totally agree. What excites you the most about the future of haptics?
I think the thing that I'm most interested in is seeing how haptics integrates with information transfer to people in the real world. If you had asked me this maybe 10, 15, or even 20 years ago, I probably would have said virtual reality and the metaverse. I think I'm much more interested now in living in the real world. And so I'm excited about seeing how haptics helps in scenarios like social touch, calming people before a medical procedure, for example, being able to teleoperate a robot in whether it's a medical scenario or in a training, what would eventually be an autonomous robot to do a challenging task. And when I'm talking about haptics, I'm talking about feedback to people and that aspect of the field. And so doing this in the real world, communication between people and robots, those are the things that I'm most excited about in terms of the impact that they'll have on people's lives.
Mm, well said. Yeah, so for us to achieve that, what challenges do you see lie ahead?
Yeah, I think one challenge lying ahead, but I think also exists currently, and why maybe we don't see haptics in as many commercial products as we would like, is that the actuation aspect is challenging. They're very power hungry. And
Mm,
so maybe this will be solved by the smart materials I mentioned, but the challenge is how do we provide significant actuation that is above human perceptual thresholds over long periods of time in ways that are actually going to be useful in real world applications. So I see significant actuation over long periods of time with low power as a big challenge.
yeah, so you sort of partially answered my next question already. So I was going to ask, what is most needed for us to, sort of advance the field in the next decade. So you already talked about actuation. Um, what else comes to mind? What about sensing? What about form factor? What about killer app?
Yeah, it's interesting. So actuation, I think, is really important. There are a lot of areas where sensing is important, although my personal research bias has been to maybe try to get things to work correctly without having to close the loop, without having to rely on sensors. So personally, I would like to avoid having to do a whole lot of sensor development to make haptic devices work. For me, probably the most important development is not necessarily technological, but more scientific. Like we still don't fully understand how humans perceive. Like how do we go from a mechanical stimulus to something we interpret in the brain? And so what we have to do in our field is we run many user studies, many human subjects and participant-based experiments, which is always important to do because there might be unpredicted results. But we don't even have models really, for the most part, available to us to help us optimize the design of our devices. And so I still think there's a huge need for basic fundamental research in human perception and sensory motor control so that we can have some predictions and models for how devices should be created that will create certain impacts on the human user. So whether that's basic neuroscientists or psychology or engineers creating different types of user studies that help us identify models rather than just how people interact with a device, I think those are really important.
Yeah, thank you. So you're one of those people who've also putting a lot of effort in growing the community, and not just haptics, robotics, and all that. Do you have suggestions for how we may further grow our community, given how multidisciplinary we are?
Yeah, it's interesting. In some ways, it's always surprising to me how small our community is. because it is very interdisciplinary. We draw from people in a lot of areas. I think it's very inspirational for students. I feel like maybe one of the challenges for why haptics is not a bigger research community is that it's difficult sometimes to say how haptics, the sense of touch, affects the bottom line in commercial applications, right? Right now, for example, in robotics, there's a huge craze about humanoids, and there's this very simple but not entirely true story that humanoids will replace human workers, and so there'll be billions and billions of dollars that could be made if you do that. And maybe hapticists like myself also believe that humans should remain in the loop, and so my suggestion is if that we can find better ways of using haptics to keep people in the loop in critical tasks, not only for humanity, but also just because we think performance will be better than, say, an autonomous robot. I think we do a better job if we work with and inform better people who are working on autonomous robots about what advantages you can have when you couple robotic and human inputs together. And that's kind of a hypothesis. I have no proof that will be the case. But for a combination of keeping humanity and hopefully being able to create robots that are more effective, if we can bring more traditional roboticists into haptics and see how we can work together, that would be my suggestion.
So for someone who's new, who's entering the field, what wisdom, what advice would you give them?
So it's already been mentioned that this is a very interdisciplinary field. And so that can be intimidating. You can go into a field and think, oh, I have to understand everything about human touch. I have to understand everything about maybe medicine if I'm doing medical applications. And then I also have to understand how to engineer the devices. And it's just not really possible for one person, at least at the beginning, to learn about all of those things. And so what I recommend to students in my lab is start by building on what you know and talk to people who are experts in those other fields and get feedback on the thing that you are doing that's based on what you know. And then you start to pick up and you start to learn these other interdisciplinary topics, and you get it through a combination of osmosis and study, but you can never get all the background you need before you get started. Otherwise, you'll never get started. So start with what you know and talk to other people to build on that.
Great advice. So before we conclude, Allison, is there something else that I have not touched on you'd like to comment on?
One other thing I was going to mention, which also has to do with understanding human touch and some of the fundamental science, is that we do a lot of studies within our own research labs, which means certain types of demographics of users. So our human subject population is not very broad. They tend to be young people in their 20s and have other demographic similarities. And it's going to be really important if we think about commercial applications to understand better how touch changes over the lifespan, how different types of skin or manual labor experience affects sense of touch. And there has been some work done on this area. It's not like nothing has been done, but because it's much easier for us to do studies within our own research groups and human subjects that are easy to access, it's hard to put in that extra effort to understand how these devices perform with a larger population. So that's something our field, I think, needs to continue to work on.